Okay, so far we've been doing some pretty basic stuff. We have this pawn that responds to input. It moves around relatively slowly. We can change that. In fact, let's do that. Let's do that quickly, but then we're going to end up destroying all of this. But we can basically, given the tools that we have, the ability, we know how to create variables, we can actually kind of supercharge its movement. Let's just say we want it to move faster. All right, so we want it to move faster. We may be able to say, we take this axis value, which in this case is between -1 and 1, and I'm going to hold Alt and click on this to delete the pin here. We may want a variable that's move speed, right? So if I click this and I choose, click this, meaning make a new variable, and I say movement speed, and its integer is fine. Movement speed, movement multiplier. That's I think what I'll do, because we're going to multiply. And we can take this axis value, and again, if we drag off and we just do an asterisk, you see that we can say int times float. And so we can take this movement multiplier, let's compile, and I think we, instead of 0, we should default it to 1, otherwise the player can't move, right? And we want to expose this outside of the blueprint. Maybe we want some other things to be able to change it. And then go ahead and drag it in and get it. And now, again, if you really like your blueprints clean, we can try to not cross wire. It doesn't matter. Okay. That's fine. So we're going to take this movement multiplier value, which currently is 1, and we're going to times it times whatever we get from the axis. And we're going to plug that into x. Okay. Compile. And in the spirit of testing always, let's go ahead and play W, and just since we're just doing the forward back, I'm just WS. And if we go ahead and select our pawn, we see now we have this movement multiplier. Let's change it to 2 and play. Definitely faster. And for fun, I don't know, whatever's going to happen there, 50. Yeah, crazy. Okay, so now we're basically taking that value and we're passing it along here, creating this new location, right? I pressed Alt again to delete that. Just we're now saying instead of X is 1 every single frame based on the frame difference, we're saying X is 50 in that particular case. That's crazy. Maybe we keep it to like 2 or 3. And we can do the same thing here. We could take that same multiplier and we can add it in to this. Get that, drag off, do a asterisk, and we can say, int times float, and then plug those two things in and have that be the y value. And now we kind of have now we have movement that's a little bit faster, not so rinky-dink. Maybe 5 is good. Now you might be building an experience where you don't want the player to move around this fast, right? You want them to move quite slowly. And in our game design document, every time you eat a taco, you're supposed to slow down, right? So we can already see now, we have this movement multiplier variable. We could almost say, we could have every time you eat a taco, we just do movement multiplier -1. So you may start out at 10, and you're moving really fast. That's very fast. And then, by the time you're full of tacos, you're moving like back at our original move speed, which was 1. And we kind of already have a way to implement some of the mechanics, except you don't know how to pass values back and forth yet between actors, but we'll learn how to do that quite easily pretty soon. So then I say we do all this work, and it's like, well, we're building something up, Christian, right? Yes, no, we're not. Actually, like, we could use this pawn, and the pawn is provided, to you as a as an actor that receives input and can be controlled by a player or an AI. But it's not for our purposes. There's probably a better way. Like here we are building in like all this movement forward, back, and then, you know, we have this jump action here that we were going to make for super jumping, and that's fine. And we could actually continue to build out our pawn to enable it to have some movement. But when you think about, at least in the game that we're making, when you think about the kind of what the requirements are, what the player is expecting, like they're certainly not going to be expecting to move around like this in the world. And they may expect a little bit more. We still have that printing. They may be expecting more functionality, right? And you may also need to know if the player's falling. You know when they're jumping, but there's a lot of other kind of gameplay systems and other things that the engine can provide to you that don't come directly in the pawn. So this is not to say we don't want to use the pawn. In fact, for your own experience, you may decide, no, Christian, I'm going to build in all of this functionality directly into my pawn. I don't need to use some of the other classes that the engine provides to help me, but in our case, we're going to. So I kind of want to talk about first a couple of differences. So let's take our pawn, and we're going to delete it from our world. We can keep it here. Be sure to save. Excellent. And now in these blueprints, I think I'm going to make a new folder. So right-click on Content, New Folder, and let's make one called Player. Great. And then we're going to right-click in here, choose a new blueprint class. And so you notice you may have read some of these before. We immediately chose pawn because we were interested in getting some input, and we were interested in controlling something, our sphere. But right below it, we have a character. So a character is a type of pawn that includes the ability to walk around. So kind of the way that I think about this is a pawn in Unreal Engine it's an actor. Basically, it's an agent in the world. And these controllers can possess that pawn. If you see below, it says player controller is an actor responsible for controlling a pawn used by the player. Controllers themselves can possess pawns. So there's a player controller, but there's also an AI controller that we're going to build that possesses a pawn, and is not the player controlling it, it's an AI. And this is basically like that's the framework. But one level down from a character is one level down, from a pawn is a character, and that's a humanoid style pawn. So it's something that can walk around, and it has a bunch of things included, and we're going to see that in a second. And the real big thing it has is something called a character movement component. And the character movement component kind of can replicate, it's just basic human-like movement. So in our game, you're a human character, and you're running around and you're eating tacos. So for us, it makes a lot of sense, rather than recreate the wheel, to use a character. But as I'm going through this, and the other thing that a character can do, and it has built in, is a bunch of interfaces to help it replicate movement across a network. So if you're familiar with PUBG, their early versions, probably they're still the same. Their version, probably even today, is an extension of the character class. Because they're replicating movement for a bunch of players around a map. And since we're not doing that, it's still, we could, but we are going to be having a human character. So I'm going to make a new character. And because it's a blueprint, I'm still going to go BP _, and let's call it player character. And enter. And there's a little person. Or little humanoid kind of thing. Double click that, and this looks a little bit different, right? And remember I mentioned it comes along with some things, and those things are inherited from the class. And by inherited from the class, what I mean is, unless you're going to program C++, you're stuck with it, right? So it's not such a bad thing. For example, we have this capsule component, which we'll use when we talk about physics collision. You have an arrow, which is just a simple thing to help you figure out, what way is forward when you're placing things in the world. And then we have a mesh. And this particular mesh, and we'll go into meshes quite a lot, cool word, right, is a skeletal mesh. And that means that it's special, and that it has a skeleton, and that skeleton can be driven by animations. And we're going to cover all of those things in due time. But for now, just know that it has those things included. And it's not like we can't put more. We can add all sorts of other components. But those are the things that it comes with. And then it has one other component that's abstract called character movement. And if we select character movement and look in the details, there's a bunch of cool stuff here, right? So we have character movement, jumping, falling. So you see this Z velocity, the deceleration, air control, boost multipliers. All of these things come included in the character class and can be changed directly here. So we don't have to control it. So if air control mattered, or matters as you're doing your playtesting, like the biggest thing that's going to be the biggest hurdle that you're going to face many times is like you're watching somebody play it and you're like, whoa, I really wish like there was some other way. It seems like there's something that's wrong with how they jump, or they're jumping too fast, or blah, blah. And then you end up having to go in and either create a new function, or you end up having to edit these values or these variables that you passed into whatever functions you made. So here it comes included, and it's not everything, but it's quite a lot. And you have things like general settings like gravity and acceleration and friction. When they're walking, right, you have specific steps for when they're walking. If they're swimming, if you really want to swim, you have a swim speed. You can fly. Right. And then here's this other thing I mentioned, which is around networking, right? How do you rotate, right? And networking we can ignore, but you have things like, physics interaction. And so these are super, super useful, at least in our particular case. We won't use a lot of them, but we'll use quite a bit, and we'll tweak them, and you'll be tweaking them quite a lot. But now to start, so if you choose mesh here, because mesh is the thing that's empty, and we scroll up, and we see this thing under mesh. It says skeletal mesh none. And if we select it, we see that there's like 3 skeletal meshes that happen to be in this default project that we made. One, this looks kind of weird, it's yellow. If I click it, yeah, that's not good. So that's actually so bad that it would probably deter me from being creative. So we're going to keep to our rule of programmer assets or programmer art. So skeletal cube, whatever. Let's actually leave this empty, and let's go back to our old friend, the sphere. So I'm actually going to add a component, and I'm going to add a sphere. What's a little strange here, though, is we have this capsule that doesn't seem to really fit our sphere. So maybe we don't want a sphere. Maybe I'm going to delete that. What if we have a... Let's just do a static mesh, which is something we can assign, right? When we were doing things like adding a sphere, that was essentially adding a static mesh. Adding a static mesh component will let us choose what we want. And I'm just looking for something else like a capsule. Okay, and I just typed cap and narrow capsule, wide capsule. Let's see the other one. Narrow one for sure. Okay. Narrow capsule. Okay, and I'm going to place this inside. And if you choose your capsule component here, which is the root meaning it's the top here, we choose this. We want to just adjust the shape of that capsule, right? So what I'm doing here is just I'm clicking left with my mouse button, dragging around. Capsule radius. So why do I want to get this like this? Well, because it's going to impact my physics collision, and I just happen to be like very specific in terms of how I like my physics collision to work, which is I like it to be almost perfect. And so, I mean, I'll leave, I'm gonna guess at 25 and then 50 maybe. Okay, good. It's 25 and 50. And you can't even see it. Okay, and then this arrow component, I'm gonna go ahead. Okay, so that's it. So I'll save it, go back here, and then drag my character in. And what's neat is if you notice what I did, I just kind of dragged it here, and because it has this capsule component, it's going to know that it should be colliding with the ground here. And so that looks pretty neat. So now if I play, I mean, there's nothing. And again, I need a camera. So if we recall, we have our pawn here, and we have all this, and all this work that we did. Kind of throwing it away. Well, we're back now. Our new character is this player character. Right, we can keep the pawn open to reference it a little bit, but we need a camera. So let's go ahead. Since we know camera, we can put a camera here and kind of place it and just play very quickly. What's happening? Can you guess? Well, here's what's happening. So we're not we're not possessing this player character here. We want to. So if we scroll down, if we select this in the world outlier, this being the player character, and we scroll a lot, we see again auto possess player. And so in a later video, we're going to set up something called a game mode, which will do all of these things for us automatically, so we don't have to worry about, saying that we want to possess this player. But for now, because we're still doing a lot of testing, well, we're always going to be doing it. We want to say auto possess player 0, and then we're good, right? So now we're auto possessing player 0, and as we drag this, we can kind of see the camera. And what's really neat now that we have a player character is we can almost, if you look in the lower right, you can see the view that the camera is going to have. So in this case, I don't like it. And we are going to set up something very cool called a spring arm with the camera, which is, think of that like a way for the camera to detect if something's blocking its view of its target or the player, and then it will move closer. You see this in a lot of games, and it's also the source of quite a lot of frustration from players. But for now, let's go ahead and see if we can't place this up here, and then maybe rotate it. Not great, but not terrible. And maybe go up and then up. Better? No? Yeah, okay, done. That's how I like it. Perfect. Now if we play, well, we've got no way to move, right? So you're like, oh, really? We have to add all that stuff again? You don't need to add it in the way that we were adding it before, because, again, we're using a character that's inheriting from the pawn class but has a bunch of goodies already built in. And a lot of those goodies have to do with moving around. But we still need our inputs, right? So we have, let's see, what input should we do? We did jump, right? Oh, wow. So now we type jump, and there's all sorts of other things that are available to us here. We have this event on jumped, which we didn't make. So the character, oh, there it is. Input, action events, jump. Okay. I'm going to delete these two, just because I don't like them there. Pressed. And now we were like, well, we had a bunch of print screens. Is the character jumping? Like, how long have they held the spacebar down? Yada yada. In our case, because we have a character, we can just type the word jump. Wow, what? Just jump. So now if we save this and we mouse over this jump, we see what it's going to do. Make the character jump on the next update. If you want your character to jump according to the time that the jump key is held, then you can set jump key hold time to some non-zero value. When you're on the jump Z velocity. Wow. So how cool is that? Like, it's basically got all this built-in stuff for us that was probably done by someone who spent like half their life thinking about this stuff. So it's actually really useful to us, right? So there is some value in taking on this character instead of using a pawn. So that's neat. But for now, I just did that, and I'm interested in what's going to happen. So if I go ahead to sandbox and press play, and now I'm going to spacebar, what? I'm jumping. I'm already jumping. That's pretty cool. So if I sound surprised, I'm pretty surprised because that's fast. And back in my day, we used to have to do a lot of calculations before this thing would even take off. So great, we did jump. In fact, it's so small that I think we want to do, we don't even want to comment it right now. We may want to do some more input. So we have another one which is like move forward, back, forward, back, forward, something. There we go. Axis events, forward, back. For this one, do we want to add a local rotation? Do we want to? No, we don't, because it's not. If jump was that easy, then something's going to be pretty simple here. So we have the character node or hierarchy here. Let's expand it so we can read. Ooh, crouch. Okay, anyway, I'm getting... That's not so good. Assign, bind, unbind. Okay. Input. Oh, wait, pawn. There we go. There's something. Add movement input. Add movement input along given world direction vector. Scale by scale value. And scale value in our case. Well, let's choose it. Okay. This looks quite similar. World direction, target, scale value. So what world direction? Well, we kind of know scale value is going to be this axis value, right? And then world direction. Well, now, I guess it was just x1, right? So, right, that would be like move forward and back. Okay. Let's just try that. Oh, by the way, you can already see, like we had this, but now we're using the character. We really just have these two nodes here. Okay, so play. Yay, it works. Oh, and look, since it has a capsule collider, it's actually colliding with our geometry. And I'm going back and I'm going forward. Neat. Right, and then we can do the same thing with left and right. And in this case, we just want to add movement input along the y axis. Okay. And if you press play, and then I'm going right, left, and then I can jump, and I'm floating in the air, right? That's already kind of fun. So if that was your movement scheme, then bravo. I mean, you can start to, I'm gonna X out and maybe you just go to some geometry and go to basic here so we don't have to, we can have some built-in things like cubes. Put a cube in there and maybe a cone for him and press R and make it a big cone. And then play and try to, I don't know, jump on top of the cube. Yes, maybe, whatever. Okay, let's delete those. So I hope that was useful. I have some ideas. I mean, I I don't like that input scheme. We're just going left, right, and forward, back. But if that's, if that's good enough for you, for your kind of your version of the project that we're making, if that's kind of how you would want to have your input sorted out, then that's fine. But many people, many games, and our game specifically, we want the player to turn around. And that introduces a little bit more thought. So we definitely see like input axis left and right. Now we want that to turn. And turning, so we were working kind of with one part of our transform, which is location. And we want to work with the second one here, which is rotation. So turning is, in our world, is a rotation along the Z, right? So you want the character to, turn 90 degrees, positive or negative. That's how we want to handle this. So instead of like working with, world direction, we want to work with something, we want to work with rotation. So if I type in rotation, I don't know what I'm going to get, but I'm going to try to type it in properly. Okay. Set actor relative rotation. Set actor rotation. Add local rotation. Add actor local rotation. So that would probably work. I'm wondering if there's like other stuff related to movement that they might have. Pawn movement, consume input vector, add movement vector. That's underneath the pawn, right? So if I right click in this, I choose pawn. And then I go to component input, maybe. Oh, this is better. Yes. Okay. See, this is why we search here instead of just immediately jump to something we saw before, is because this looks like what we want. Pitch, roll, yaw. So just so you know what pitch, roll, and yaw are, that corresponds to the rotation. So if we mouse over this here, roll is this, right? Rolling. Pitch is here, pitching forward, pitching back. And then yaw is this, yawing. Yaw. Okay, funny word. So that's what we want. You want a yaw. Add controller yaw input. Oh, see, that's even better because I was already kind of dreading if we would have used the local rotation, like local rotation. We would have had like this rotator that we would have had to figure out, like do some things here. In this case, kind of have like just one, and it's already a float. Amount to add to yaw. This value is multiplied by the player controller's input yaw scale value, which is even better because once we add a player controller, which is just the interface between the pawn, or in this case the character, and the human, then we can even set more of these values, and we can set them on a per player basis, which is very cool. So I just did that. I'm going to compile, and now I'm going to play, and I'm just going to try my A and D keys. That's A, and that's D. And wow, I'm spinning around. So that's very cool. So now in our world, we would, oh my gosh, I should know like which way is forward. Well, obviously forward is always forward, right? Because I'm rotating. And if I press W and S, wait, yeah. So we have a little problem here. So now we're like locked onto our x-axis. So this is why you do things in baby steps. So let's exit out of this and take a look at what we think might be going wrong. So I'll give you a second before I tell you. But this is our player character, right? So we have these nodes, and we have already the ability to jump and the ability to turn and the ability to go forward and back. But if you caught it, it's this here. So this world direction is fixed at x1. And what we really want in the world direction is we want that to be some, well, basically we want it to be in English the direction that the player is facing when we press W. Right, so that's how we want to move forward. And so what do we need to do to get that? Well, so I kind of said it. So the direction the player is facing. So we want to take a look at, let's take this particular character here. And if we right click, let's just type the word forward. Okay, already. Get forward vector in rotation. Okay, and so if we got the forward vector, that's essentially saying what direction is forward based on the current rotation of the player. So now we need a way to get the current rotation of the player. So if we drag off the other side of this, there's kind of a way of working backwards. We can just say, well, we know this is a character, which is a pawn. If we type character, it's not working. If we type pawn, no. If we type, well, this is an actor, right? So we just type rotation, and then we might type actor and rotation. Oh, we just type actor. Get actor rotation, returns rotation of the root component of this actor. Okay, so this should be the direction that it's facing, right? And then we get the forward vector of that. We make a vector 3, which is x, y, and z that represents where the forward is. And that's what our world direction is going to be. I disconnected some things, and we want our scale value to be based on our axis value. And now let's compile that and play it. And I'm going to turn and press W. And I'm going forward. That's cool. All right? And I can jump. All right, so that's the end of this video. In fact, because that's kind of what we want to have in terms of our game. The player's going to move around, and we don't want to have them just be able to strafe left and right. We want them to be able to turn and move forward from there. So just to kind of cap this off, what we did is we took, we had been working in a simple pawn here, which was moving back and forth and was left and right, and we had, decided that we were going to toss that and make it a little simpler by using built-in functions that come with the character, which is a humanoid style pawn, and it has a component for collision, and it has a bunch of functions here that target the pawn that it has, right? So in this case, particularly like things like add movement input or jump, and it has lots of other things that you can set that we really haven't gotten into. But if you want to play around, you can take what we built here. You can select the character movement component here, and you can change some of these values, right? You can change the gravity scale to 0.5, and then if we go back and play and you press jump, it's going to be, the gravity will affect it in a different way. And so there's quite a lot you can do just in the mechanics side directly through using the character instead of the pawn. So we did that. We also kind of made a quick change to, we noticed a problem, a pretty obvious glaring one, which is in the way that we were moving and adding our movement input. And we showed how we were able to kind of get this rotation, translate that into what's called a forward vector, and then feed that into our function here. And we end up with kind of a definitely like a sandbox that we can start to build our game around. Cool.